So I am indeed Alan Pike. I work at Steam Clock Software, all the way in Vancouver, Canada. And what we get excited about is building delightful apps. That's what we do. That's what we're passionate about. That's what gets us up in the morning. And although we often do that using native technology on iOS, Android, and generally mobile platforms, we also really love JavaScript. We use it on the server. We want to use it as much as we can in our apps. And so that's why today we're going to embed a JavaScript runtime. It's going to be a lot of fun. And we're going to do that so that we can embrace our platforms, enable tinkering, render native OpenGL, mix JavaScript and native code, and share JavaScript in between native apps. So that sounds fun, right? Let's do it. So the motivation behind this all, of why are we even looking at native technology, is to build delightful apps. So what do I mean when I say that? I mean not just apps that work, that do what they need to do, but apps that are really cool, apps that are delightful, that have fascinating UI, that performs extremely well, beautiful touch interactions, that are fun, that are quirky, and that get people excited and say, how did they even do that? Or how did they even think of that UI? It's just so great to use. And so that's what gets us really exciting, is blowing people's minds. And often that means that we need to reach into our native UI toolkits or OpenGL or some of these other technologies to do that, but we still want to use JavaScript as much as possible. So we're going to embed a JavaScript runtime. It's going to be a lot of fun, and it's really easy. All you need to do is git clone v8, so that's pretty easy. And then you just check out the build steps, go through that. A few hours later, you have V8 built on your machine. It's really awesome. And then you're going to consult the V8 Embedders Guide, which has a lot of really handy information. For example, note, the handle stack is not part of the C++ call stack, but the handle scopes are embedded in the C++ stack. Handle scopes can only be stack allocated, not allocated with new. You know what? On second thought, let's not do that. I'm going to tell you a story instead. So some time ago, maybe 4 or 5 months ago, Steam Clock, we were browsing through the WebKit repo, as you do, and we were looking at what would be involved to embed JavaScript core into our apps. And Nigel Brook, he came across something really interesting, a series of commits. And these commits started on New Year's Eve. Everyone else was out partying, drinking, getting crazy. And some Apple engineers were getting crazy as well. But they were getting crazy adding something very interesting to JavaScript core, an Objective-C API. So Nigel finds this, and he sort of like, hey, cool, look at this. And I'm like, oh my God, we have to write about this. We have to build stuff on this. We got to we got to pull this out. And so we did. We wrote about it, and we shared sort of a Hello World project on GitHub. And a lot of you thought that was really cool and gave us some great feedback on it, and we're really excited. Finding this thing in the WebKit repo, though, didn't answer the questions that we had, the really big question, which is, why are they doing this? What is this for? Is this something that's going to ship in one of the operating systems? And if it is, which one? Well, thankfully, just a few weeks later, maybe about a month later, came WWDC. And with WWDC came a giant NDA. It was great. Of course, it was. This is the iOS 6 NDA. The iOS 7 NDA looks like that. So it's a little bit different. The effect was the same, though, which is that Apple doesn't want us publicizing stuff about beta APIs, which might change or might go away entirely, which I totally understand. Thankfully for all of you, JSConf EU comes at the exact right time, because on Tuesday, Apple announced iOS 7. They released it, it's GM, it's done, and all the APIs are final. So I can actually now confide in you that on iOS 7, as well as macOS 10.9, there's a new API. It's a public API called JavaScript Core Framework. And that's built right into the operating system. It's public, it's maintained by Apple, and it's an Objective-C to JavaScript bridge. Hey, cool, a free JavaScript bridge. So what does that exactly mean? Like, what does a JavaScript bridge look like? Well, ideally, a JavaScript bridge lets JavaScript be JavaScript, right? Your JavaScripts will still, if they've done their job right, your JavaScript will still look like the JavaScript you would normally write, except that you can interface with native code. So let's take a look at some examples. What does that look like? So we've got a JavaScript function here. JavaScript's really great at math, so we want to help Objective-C code do math with JavaScript because it's just so great at it. So we define a multiply function, and it looks just like a multiply function. It's what you would expect. It's cool. So that's cool. And now that we've defined that in Objective-C, we can go evaluate that script. So we use this thing called JSContext. I've instantiated one here. I evaluate the script, and then I can reach in to that JavaScript context and pull out the multiply function. Once you have a handle on it in Objective-C, you can call it using this call with arguments thing. If you're not familiar with Objective-C syntax, this crazy basket of @signs and square brackets in the bottom right corner is passing arguments into this JavaScript function. So what I'm defining here is native Objective-C number types. They get passed over to JavaScript, and JavaScript can work with them as numbers, just as they would expect. And then when it returns back to Objective-C, we can get that value out of JavaScript, and we can cast it to an integer or whatever. So our statically typed and our JavaScript world, they work well together. So that's great. Our JavaScript looks like JavaScript. What happens if we go the other direction? So let's take a look at that same multiply function in Objective-C. It's beautiful. So I don't know, maybe that's why we're writing JavaScript instead of Objective-C if we can. This is actually the block syntax in Objective-C for defining the exact same thing that we did in JavaScript. And you get used to that, and it makes sense. It just takes two integers, multiplies them, returns it. It's great. So we define our multiply function in Objective-C, and then in exactly like we did in the last example, we can reach into the JavaScript context, and then we can actually, we can just say, okay, hey, I've defined this thing called multiply, you have it, and now you can work with it. So in JavaScript, it looks like as simple as it could possibly be. We just have multiply. And when we call that multiply, we pass in the 1 and 2. They get cast to ints on the Objective-C side. We get our multiplication back, and this in JavaScript. So that's pretty cool, right? Like, you know, we got JavaScript Objective-C going back, and for a one-liner multiply, obviously that's not going to, like, you know, shake the world or change anything fundamentally, but it sort of gives you an idea of what this API can do. So how do we do it? What is the API? Well, there's three main classes that you care about if you care about this API, and the big one is JSContext. This basically loads a JavaScript VM, and you can throw JavaScript files into it. And it's what we're using to reach in and take objects out of the JavaScript runtime, the JavaScript context into the Objective-C world, and put them back. So this is kind of your workhorse class. But then there's two helper classes that allow us to go in each direction. There's something called JSExport, which is a protocol. A protocol is Objective-C-ism that basically is an annotation. So you can say, hey, this particular Objective-C class, I want it to be bridged over the JavaScript side. So it's really easy to do that for your own classes. It's basically trivial. There's a little bit of boilerplate if you want to JS export an existing Objective-C class that you don't have the source for, but you can write a script that will automate that, and that's something that we're planning to do ourselves. So JSExport, and then going in the other direction, we have JSValue. And so JSValue is object for encapsulating a JavaScript value in the Objective-C world, because of course, like, we can't have these like crazy typeless things in Objective-C. We need to make sure that we know exactly what's going on with them. So JSValue lets us hold on to JavaScript types and cast them to various things. So that's all very cool. What does that bring us? You know, so we've got all these things put together. What is the equation here? We got JavaScript core, right? And we've had JavaScript core on mobile for a long time. It's part of mobile Safari. But now we can instantiate it without a web view using public APIs. We don't have to actually go through that build your own, package your own. So that's cool. We don't have the memory overhead or the startup overhead of starting a web view, and we also get this nice bridging functionality, which is cool. So that's what we get that we like. There's something that we get that we wouldn't have really missed if we didn't have it, and that's this idea of reference cycles. So Objective-C is not garbage collected. It's a reference counting language. And the compiler automatically counts references for you, and it cleans up memory when nothing is pointing to it. But the key is that it only cleans up memory when nothing is pointing to it. So you could have like two objects that point to each other, and if the rest of the object graph doesn't point to it, then the runtime is not going to know that that's a reference cycle and it needs to be garbage collected. So that's something we don't normally have to deal with in JavaScript. And so if you're not familiar with working with Objective-C and you're sort of experimenting with this, I recommend you check out the WWDC video from this past June on how to avoid. It's generally on this JavaScript stuff, but the kind of gold in there is avoiding reference cycles. So that's kind of annoying, but what do we get in return? We get this more flexibility, right? We get all these new things that are easier, and we can do stuff like instantiate multiple JavaScript contexts and having them run on different threads really easily. And we actually suspect that it may be possible to instantiate a JavaScript context, have the JavaScript get parsed, and then write that out to disk and then restore it later for faster startup times. So that's something we want to experiment with. And this is the kind of stuff that, like, you try to do that with a web view, like, oh, God help you. So, I mean, maybe it's possible, I don't know. But all this stuff comes together to make for some delightful possibilities. There's stuff that we're not exactly sure. I mean, this thing, like iOS 7 is just coming out basically now, right? So we don't exactly know all the things that are going to shake out of this, but there's definitely some really cool possibilities. So, what kind of possibilities? One that's dear to my heart is embracing our platforms. And when I say that, I mean the different mobile platforms that our users are using, and the ones they're using for particular reasons, right? And as web developers, especially when we're building like in a web view, we tend not to, we sort of pave over the differences in between each platform, right? Partly just because it's a pain in the butt to make your web app feel like the local operating system. And so, for example, like maybe we did all this work to make our iOS 6 app look, it's like a web app, but it looks like iOS 6, and then iOS 7 comes out and kicks us in the nuts. And it's like, okay, everything's completely different, right? Like, and sometimes it's not even that hard to do, right? Like iOS 7, we got these white backgrounds, type-heavy layouts, focus on images, flat rectangles, blue text you can click. It's really high-tech stuff, right? Or it's the web from 1997, right? It's not like we can't make these things happen in a web view. There are things that are hard, though, right? Like it has these physics-based gestures and these beautiful 3D effects. We've got this 60 frames a second scrolling on all these various places while doing a real-time blur operation on mobile, on like an iPhone like 4S class hardware, and highly responsive touch, all these cool things. And so it's kind of controversial, like, oh yeah, you can do some of these things on mobile. It's possible. Are you going to get great performance? Are you going to build a delightful app? Probably not, maybe not, at least not yet. So what does that mean? That's our iOS 7. So that means that if we build with a native UI, or at least as much as makes sense for any given app, then we can have these native looking and feeling things that will conform to what the users want and what they expect on any given platform, but still potentially write a lot of our code in JavaScript. Titanium obviously has been barking up this tree for a long time, Appcelerator guys. And I think a lot of us have played with Titanium. I've played with it before, and I find it can be pretty heavy. I've been quoted as calling Titanium a 500-pound monolith of Eclipse and licensing, which is kind of mean because technically it is not 500 pounds, it's 211 megabytes. But these guys are really smart, and they understand this problem. And when they saw the new stuff that Apple was doing at WWDC, their minds were blown, and they promptly actually embarked on a complete rewrite of Titanium to take advantage of this approach. They're actually going to JavaScript core on every platform, porting it to Android and porting JavaScript core to Windows as well. And they're also building something called Hyperloop, which is a compiler from JavaScript into native code on each platform. So they're going totally crazy with this like JavaScript bridge stuff. And then you're rewriting something as big as Titanium, like how long is it going to take? I don't know, how many months or years. But it's definitely worth keeping an eye on what they're up to if you're interested in this stuff, because there's a lot of cool thinking and prototyping going on there at Appcelerator. So we, in general, want to enable tinkering, right? And native apps, historically, not that easy for people who are not coders or not really up on necessarily senior level people to like tinker around and just play with your Objective-C or your C or your native app. This is something that other industries have been doing for a long time, right? Like if any of you are familiar with the games industry, you know about Lua, right? Lua is this little embeddable language that most games nowadays have some sort of scripting facility for AI or for levels or various things that are not necessarily performance critical to the app, but they're written in Lua, so they're easier to toy with, and level designers can edit the Lua without having to build this giant C++ project. Well, we can do exactly the same thing, but with JavaScript, right? Because JavaScript's an incredibly performant dynamic language, and we get this bridge for free, and we can also embed the JavaScript runtime in games and anything else that we want to. So that's a really interesting way to enable tinkering. But when I think about enabling tinkering, the story that always comes to mind is the story of this. This is the Mac calculator from the original Macintosh. It was up there. It looked exactly like this all the way until Mac OS 9, so like for 15 years. And the way this calculator came about, it didn't originally look like this. There's an engineer at Apple who was employee number 8 at the time, but he was still like, hired when he was 14 or something like that. In the development of the Macintosh in 1982, he wanted to do this calculator to show off the new drawing code that the Macintosh was going to ship with. So he hacked something together. It didn't look like this, and he showed it to Steve Jobs. And Steve's like, "Oh, this is shit. Like, these fonts are wrong. This pattern is wrong. The buttons are too big. Like, change everything." So Chris goes and he changes everything, and the next day he shows it to Steve, and Steve's like, "Oh, this is shit. This is wrong. The font's wrong. Blah blah blah." Potentially even contradicting things that he told him to yesterday. So after a couple iterations of this, Chris gets wise and realizes that he shouldn't be building what Steve asked him to build. He should instead be building the Steve Jobs Calculator Construction Toolkit. So that's what he built. So this is this beautiful application. Its purpose was to let Steve tinker with all these various values and the shadows and fonts and outlines and stuff like that. And he did, and 10 minutes later, they had the calculator that we just saw that shipped for like 15 years. So I thought, what better demo for technology that makes it easier to tinker with applications than a calculator? So I'm gonna show you a calculator. So this is the iOS simulator. This is nothing because I'm not mirroring. Pardon? Command F1, cool. I'm totally going to press that. It does nothing. Unless I suck at pressing Command F1, but my understanding of... Oh, it's Command brightness down, not Command F1. Okay, cool. So this is the iOS simulator, and I'm going to make it a little bigger for you guys. It's the... yay. So this is the iOS simulator, and this is iOS 7. Okay, cool, a calculator, right? You guys have never seen a calculator before, so I'm going to show you kind of how it works. We got 58, wow, that's really cool. And so we can do all this sort of things. We can store things in memory and clear them and restore them. So it's a cool little demo app that you guys can check out on GitHub and see how we've built this. But this front end is entirely native UI, right? If we take a look, this is built in Interface Builder. There's no JavaScript code that's assembling the UI. It's entirely done in our native tools in Xcode. So when iOS new versions come out, we get all this sort of new functionality and stuff that we get in the developer tools. But we still have this thing running here in JavaScript. All of the logic is written in JavaScript. So you may be skeptical that the logic is running in JavaScript, so I should probably prove it to you. JavaScript is pretty good at math, so let's take a look here. So let's see what this equals. Yeah, that's right. And JavaScript interprets numbers starting with a 0 as octal, because that's pretty cool. So let's see what this equals. Yeah, cool. Okay, yeah, so it's JavaScript. So we've married the power of Objective-C with the math power of JavaScript and creating something pretty amazing. I think you're all going to want to check it out. OK, so that's fun. Let's undo my full screeny thing. Cool. A calculator. Awesome. So you can check this out on GitHub. We've pushed it live now, steamclock/JSCalc. And I'll post the slides, obviously, after the talk. And that's really cool, really impressive. You can do a calculator. What's more impressive, though, is rendering native OpenGL. So it's kind of opposite ends of the holy crap spectrum. And when people hear OpenGL, they tend to think games, but there's actually a lot of really great uses for OpenGL for rendering non-game applications. This is something we built recently at SteamClock called the Map the Internet. It's 3D. You can interact with it. You can zoom through time and see the history of the internet. You can do an interactive trace route. It was actually Angelina that wrote the trace route that goes through the internet in 3D. And so it's a crazy 3D application. And we've built it with C++ and OpenGL on each platform. But there's no reason that the logic that is non-performance intensive needed to be written in C++. And we realize that now, and if we were to do it today, we would probably try this JavaScript bridge stuff. We're not the first people to think of embedding JavaScript in an OpenGL app, though. There's this thing called Ejecta that you guys may have seen, and it's related to the Impact project. So Dominic Zablowski, who wrote Biolab Disaster, it was like one of the first HTML5 games that was actually like really worth playing. He's built this thing that's actually a native implementation of Canvas, Audio, and WebGL that you can deploy to iOS and run all of your existing like sort of WebGL game that runs in the browser. You can run it on iOS. And this is possible in like a web view, well, not WebGL. But the performance implications of this are that it runs way faster and with substantially, even more dramatically, with a lot less memory overhead. And so you're still using the same open technologies. He's using the same APIs, WebGL, and all that kind of stuff, but with a native backend. And obviously, we don't have WebGL and a web view on iOS yet anyway, so it's a nice sort of polyfill. So in general, there's all sorts of cool ways we can mix JavaScript and native, right? So for example, at SteamClock, we tend to build apps this way, right? We have Node on the server, which is great, obviously. We want JavaScript there. And then we'll end up building a native sort of logic layer and a UI layer, and then a native logic layer and UI layer in each platform. OK, well, that works fine, but we're writing Java. And then you're writing Java, right? So let's not do that. Let's write the logic layer in JavaScript, right? So we got the models and controllers in JavaScript and the UI layer for the views in native code. And that's great if your UI is the intensive part of your application. But what if your UI is really simple? It's some enterprise app, but you're doing some intensive number crunching or video or something like that. Maybe we do it the other way around. Right? We use web views, we use HTML on the front end, and then we have a native layer for our models and controllers, right? Or maybe we build something like Cordova WebView, or we use Cordova WebView. So most of you are familiar with PhoneGap, Apache Cordova. Well, they have a component where you can drop Cordova into your application, so it's sort of side by side. You can have your native UI code, your native models and controllers, and then you can also have your web technology, your WebView models and controllers in JavaScript. And so my point is that however you mix these technologies, if they're the right solution for your app, then they're the right solution, right? Like even if this is the right solution for your app, right? That's probably not the right solution for your app. I would not recommend that particular architecture. But the point is that there's lots of opportunities for sharing JavaScript. And we want to share JavaScript in our native apps. So of course, we built this demo showing the calculator on iOS, but we would be totally remiss if we didn't get it running on Android, right? Thankfully, there's a JavaScript runtime called Rhino, which most of you probably haven't heard of. It's been around for a while, but it's written in Java, so it's extremely easy to embed on Android. So I'm just going to quickly show that to prove to you guys that, I need to do my little dance again. So I'm going to show you guys this thing running on Android. Cool, yeah, an Android. OK, so this is the exact same calculator. It uses the exact same JavaScript, but is, again, built with a native UI. And so just in case you guys are still skeptical of my claims, let's type 16 nines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's see what that's equal to. Right, 10 quadrillion. Yeah, OK. Slow clap. OK, great. So this is still on GitHub, and you can try that out on both platforms. What's the point of all of this? What's the takeaway? I've shown all these different demos and ways that we can use JavaScript, we can mix JavaScript. I just want to encourage you to try embedding a JavaScript runtime. Whether you go through the V8 instructions, whether you use the iOS 7 APIs, you embed Rhino, you embed JavaScript core, try it out. So with that, I encourage you to go out and go build delightful apps.